Location at the Government 2.0 conference in downtown Washington, D.C. This is a conference sponsored by O'Reilly Media, and we're pleased to be joined and to introduce you to Dan Reed, who is a corporate vice president for Microsoft. He's a vice president for technology strategy, among other things. Mr. Reed, what exactly is your job?
So I do a variety of things. One is my job is to envision what the future of technology will be. Think about its broad societal implications and talk about those things around the world in a pre-competitive way to say, this is the future, this is what it potentially means for us. Let's talk about how we adapt to that future, how we plan for it, how we exploit it. The other part of my job is to try to invent the future. So I spend a lot of time building advanced prototypes of things that we think those technology trends will make possible.
When you think about inventing the future, what specifically have you thought about?
Well, we think, for example, about the future of human-computer interaction. We've largely been in a mode for the last roughly 40 years of a model that's based on windows and mice and pointers in a generic sense. It's not just a Microsoft technology, but that's our standard mode of interaction. And there's an opportunity for a new model to move computing from a passive mode where your computer literally doesn't do anything unless you poke it, to one where it becomes an intelligent assistant that anticipates your needs and it allows you to interact with it in the same natural ways that you'd interact with other people.
Such as, give an example.
Speech, gestures, the way that we communicate, body language, emotional context, social awareness of what a group of people is doing and what their objectives are. I mean, in some ways, you'd like your computer to be much like a wonderful human assistant, to make you look better than you really are, to anticipate the things you do. When you say, you know, I bet we should do this, they say, already did.
Well, some of that technology is already around, isn't it? I mean, such as voice recognition on a phone and the Wii system, the Sony Wii system when it comes to playing tennis or whatever sport you want on your Game Boy.
So the challenge really is to bring the technologies together. So an example of one of those things that we're really excited about is a Microsoft Kinect system, an extension of Xbox that will appear later this year. It actually is a controller-less interaction system. You can speak to it, you really can use gestures. That's the only mechanism. Cameras recognize your behavior and they respond automatically to you. So you walk up and you start to play. And that's an early example of this sort of broader notion of, I don't need a set of electronic tools, I want to walk up and talk to someone, I want to start some activities going. And it's just really about bringing the things together. And one of the enablers, and one of the reasons why I'm here today, is to think about how we use wireless spectrum to allow all of those sensors to communicate and interact.
And how do we? Or how will we?
Well, that's one of the challenges. I think as we look at what's happened in computing technology over the last 50 years, the steady trend has been one of democratization. At the end of the Second World War, there was effectively one computer per planet. And that was an outcome of early radar and other ballistics calculations. That's when the modern computer era was born. But we went from that era to a world of mainframes where people in the priesthood prayed to the big machine behind the glass, to a world of mini computers that have started to appear in laboratories and automation, workstations, PCs, smartphones. And there's a world coming beyond that where intelligence is embedded in everyday objects because powerful and really inexpensive processors, sensors that can capture data, those are the enabling technologies for this notion of natural interaction.
On your blog, you refer to Alvin Toffler's book, Future Shock. Why is that such an important book?
Well, it goes back to your question about what's my job, about envisioning the future. And one of the clear trends that we see is that the insatiable demand for wireless communication, and we all know that. Anytime you've turned on your phone and hadn't been able to get a signal, or you dropped a call, or you couldn't get a data connection, it's no one's fault. It's just there's an incredible exponential growth in consumer expectations for that bandwidth. And yet the historical models we've used to allocate bandwidth date back to a period when vacuum tubes were the state of the art for radio technology. and what we call plain old telephone service, a landline with a bakelite phone that you picked up and spoke to Mall Bell, was a state-of-the-art of communication. And so the social process about how we allocate spectrum to these functions is defined by a rate of technology change that evolved over a time scale of years. And now our expectations are to roll out new services and respond to consumer expectations in a period of weeks or months. And so that disconnect about the rising demand for spectrum and our historical approaches to manage it, that's really the future shock disconnect.
Well, one of the historical approaches to managing the spectrum has been the division of the spectrum. Is that outdated?
It's important to respect history. And as a technologist, there's always a great temptation to say, we have a better way. Forget all that stuff before. That's not the real world. You have to respect the reality of the economics and the processes and the social conventions we have. But I do believe there's a middle ground that respects that history and the investment that groups have made, but finds a middle ground that says, let's take advantage of those inexpensive but powerful processors and shift some of the capabilities that we used to build in hardware into software, because they're now fast enough to make those things possible. And what it means is, rather than allocating spectrum in a multi-year process, let the devices query a database and say, I'm here. What spectrum is available right now? What rules apply to whether I can use it? For how long can I use it? Is it licensed and therefore I need to pay? Is it unlicensed and therefore perhaps not? But allow that sort of nimble adaptation. And so it's really a two-part thing. It's a technology future that says we have a new way technically of managing spectrum because we can do things very rapidly on a context-aware basis, but it's a nimble policy framework as well that both respects the history that exists. It says all of those investments and mechanisms are still applicable, but we can provide an additional revenue market, an additional way for those folks who've made that capital investment to also capitalize on it in this new way.
Well, one of the policy debates here in Washington, Dan Reed, is whether or not public safety should have a chunk, in essence, of the spectrum. Do you think that they should? Do you think a part of the spectrum should be set aside for public safety?
So that's a very complicated question, as you know. I think one of the things that's true, whatever mechanisms we adopt, we have to respect the primacy of these critical functions. If you call a fire engine, you want it to show up quickly. You don't want it to be encumbered by the fact that some other thing was going on. That's the primary objective. I think the important debate is, what are the right technical ways to achieve that? How do we balance this diverse set of needs? But we have to respect the reality of those very real needs. I think there is a middle ground that can accommodate both.
And is this using the white spaces in the spectrum more?
So I'm not so sure that white spaces themselves are directly applicable to public safety, but white spaces more generally are an early example of this cognitive radio model, because they are a secondary user of spectrum that's a potential consequence of the switch to digital television transmission. They're secondary in the sense that broadcast is the primary use. The opportunity is to say, if the broadcaster is not using this channel in this location, it's available for this secondary purpose. But I have to respect the primacy of the primary use. And that's really, I think, the broad set of issues. Our challenge is, technically, if you turn on a spectrum analyzer, which allows you to look at what spectrum is actually in use at any given point with some reasonable radiated power, most of the time, most spectrum, most places, is fairly lightly used. And so this fixed division is our historical challenge. It's like saying this lane of the road can only be used for trucks. This lane of the road can only be used for motorcycles. That will work, but you have to build a lot more lanes. So what you really want are rules that allow mixing and matching, but respecting the fact that those functions are different.
Is there a shortage of spectrum?
There is a shortage of spectrum in certain bands, for sure. Our pressure on cellular is an example of that. At the same time, there are other bands of spectrum that are very lightly used, and that's the challenge, is to find that middle ground.
Is spectrum availability crucial to Microsoft's future success?
We believe it really matters for a wide variety of reasons. Some are societal. We believe strongly that broad access to information is a critical enabler of long-term economic growth in this country. And so we've been a strong advocate in the National Broadband Plan of fiber to anchor institutions, to hospitals, to schools, to libraries. We see things like white spaces as a potential mechanism to provide last mile access in rural areas, for example, where economics might not otherwise be viable, or for economically challenged areas in urban possibilities. So that's one aspect, but more generally, yes, we think spectrum matters because the world of client plus cloud services is really about broad access to information.
And if you would very quickly talk about cloud computing and Microsoft's role and what you see as the future.
So it goes back to where I began about the future of natural user interfaces. How do I build computing systems that can adapt and anticipate and respond? There are two aspects to that. There are the local affordances, the devices that are in your proximity, the sensors, the computing devices, the cameras, the gesture recognition systems. But there's the broad context of the world of information that attaches to that. And that's where the cloud really comes into play. The wireless communication and the smart sensors and devices are the local aspect, but the broad set of computation and cloud experience behind that is the enablement. So the aspect on the cloud is about building the massive infrastructure to extract insight from data to provide advantage. I'll give you a simple and concrete example. Think about the future of intelligent transportation systems. There are two aspects to it. One is the local sensing to understand traffic flow patterns, delays, road conditions. The other is the planning process to say, how might I route traffic? How might I control traffic signals? In a world of hybrid vehicles, how might I advise drivers about where there are refueling stations or electric recharging stations for electric vehicles? That's an analytic problem. It's powered by the local data. The awareness has to be delivered to the individual, but you need both of those. The cloud provides the back-end intelligence to enable the local experience.
What about the privacy concerns? Another policy debate happening here in Washington.
There are a huge set of issues around privacy that we have to address. I think historically we have viewed privacy as a binary thing. This is either private information or it's public information. In fact, there's a whole continuum of issues around that. The other thing that's historically been true is we've attached a notion to privacy to a broad set of attributes of you as an individual. And I think there's an opportunity to rethink those in terms of claims-based identity. Let me just illustrate that with an example. I'm old enough now that when I go to a restaurant and buy a drink, they usually don't ask for my ID, but there was a time when I did. The waiter who asked that question doesn't really, who typically would look at your driver's license, doesn't really need to know your name, doesn't need to know your height or weight, doesn't need to know where you live. They just need to know one thing: are you over 21? And so we've commingled this notion of identity with a specific set of information. So I think the broad issue around privacy is going to be really three attributes. Information that exists about you out on the web. One is who controls access to it? How long does the information exist? Because one at some point would like some of that data to go away. It has a bounded lifetime. And if I make it available to someone else, to whom can they give access to that data? And so all three of those issues, I think, are part of the complexity of privacy that we're going to have to sort through in this new world.
Dan Reed, when you deal with Congress or the FCC, are you finding an audience that listens to your concerns? Are you a little troubled by the policy private enterprise split?
No, we found a happy engagement because what we try to do is talk about the broad long-term perspective about where we think technology is going. And those are enablements for economic competitiveness for the future of the country. They're about global competitiveness. They're about the things that will add value to daily experience. And so as we talk about those, no, there's been a happy audience across government and engagement about those issues.
You are also Vice President of the Extreme Computing Group at Microsoft. What is that?
So that's the other part of my life where we build wild and crazy things. Just as we think about technology trends and policy, we also want to live in the future and build some examples so we can get some experience about what those futures might be. And so that includes everything from thinking about the future of cloud infrastructure, how we build much more energy efficient data centers that can be deployed in a broader array of markets that are resilient and reliable and secure because of all those privacy issues. It's about the future of natural interaction and what those devices would be and what technologies could allow interaction. It's about a broad set of issues around privacy and security. What are the future technologies around cryptography and software support for privacy that will allow you to control access to your information? So what we do is we build examples of the future and then we live in them. In fact, there's a common phrase in the industry about living in that prototype future. It's called eating your own dog food. And it means it's not quite ready for the dinner table, but it is edible. And you want to learn what the experience is because that's how you know what will work and what won't work.
Are these done in a laboratory, in a factory? Where are they done? Where are you building these?
So we're building them in partnership around the world. The primary focus of my team is work that we're doing in Redmond on the main Microsoft campus. It's a combination of hardware and software. So we build radical hardware as well as radical software. Microsoft is not just a software company.
Is it very proprietary? Is it top secret?
Certainly some of the things that we're working on we hope will influence future product directions, and we work heavily and closely with those to transfer many of the technologies. But some of our objective is to work with our industry partners and collectively shape what the future will look like, and whether it be in the context of spectrum with white spaces saying what characteristics should those devices have so that when the policy issues are resolved, the technology can be deployed quickly. So some is internal, some is in broad partnership.
Dan Reed, there's two devices here, BlackBerry and a Droid, two smartphones, I guess you'd call them, both 3G, third generation. What generation are you currently looking at? I mean, we're just talking about the rollout of fourth generation or 4G. So where are you as far as with the Extreme Computing Group?
So across Microsoft Research, and the Extreme Computing Group is part of that, we're looking at a whole variety of technologies, some of which would be applicable in the cellular world, but some of which would be not. And broadly, it's looking at where spectrum can be used, because there's some spectrum where a long-distance communication is between my two hands. That's sort of the body area network notion. It's not applicable to cellular, but it's about that world of sensors and natural experiences. And then there are other long-range technologies that, of course, cover very large distances.
When do you see 5G being deployed?
Oh, my crystal ball is perhaps not that good. I think we have to look hard at how we use all of the spectrum bands efficiently, because the one thing about this business, and I was a professor for many, many years before I went to Microsoft, that I used to tell students for years, the great thing about computing is the questions don't change, but the answers always do. And that's what makes it exciting.
You also served on the President's Science and Technology Advisory Committee. Under which president, and what did you do in that role?
So I was involved in the background in unofficial capacity with IT advisory committees under the Clinton administration. I served on the President's IT Advisory Committee under the Bush administration, the second Bush administration, and then on the President's Council of Science and Technology Advisors as well. As part of that, we looked at the future of computing and how it enables scientific discovery and computational science. We'll look broadly at the federal research investment portfolio in computing and what it means for economic competitiveness.
As far as the U.S. goes, is it still the out-and-out leader, or are we feeling pressures?
We're still a leader, but we're feeling pressure. I would say if one looked historically, we were laps ahead now we can look over our shoulder and see the world gaining.
And why?
Part of it is the inevitable democratization of technology. I think that computing has been a major driver of economic growth worldwide, and there are lots of statistics that support that. The rest of the world has recognized that and is making investments in the technology to help drive that forward. It's investing in STEM education to train a new generation of workers, and there are government investments behind that. And so many of the issues are about how we remain competitive. And I think the challenge is always to keep climbing up into the value chain to invent the future.
When it comes to government policy, is this one of the issues that you look at in helping the U.S. to remain competitive?
Absolutely. What kinds of things can we do in public-private partnerships to create the environment that will ensure long-term success for the U.S. and the U.S. economy?
Dan Reed is the Vice President of Technology and Extreme Computing at the Microsoft Corporation. Mr. Reed, you graduated from Purdue, MS in computer science in
and a PhD.
And a PhD, Dr. Reed, in 1983. What were you using in 1983? What kind of machines? What kind of software? Was there software?
Oh, well, there was software in 1983. I'm not that old. At the time, the state-of-the-art were large mainframes and the early days of mini computers. As I finished my PhD, the world of workstations was just starting to appear. That's when Sun became prominent, building machines in those early days.
And did you envision smartphones at that point and the wireless technology that we use today?
No, I don't think anyone envisioned the future that we have now. Certainly people envisioned the future of communications and what it meant. You have to remember in that time frame, the internet didn't exist. The early ARPANET was available. There was a time when I could draw a picture of the entire internet on a 3x5 card. It was in that time frame. So that was a big leap to think about that future. But people have always been envisioning the possibilities.
Is the advance in technology still growing exponentially?
It is. There's a network effect, and I don't mean just in the technical sense. There's a network effect when you get a critical mass of users and expectation that drives economic investment in small companies and large to create new capabilities. But it also stimulates the exploration and basic research in the technologies. And so to your point about what was the world like when I was a student, the technologies that exist are the base on which research is done. So at a time when the state-of-the-art was mini computers and workstations and mainframes, those are the tools of the trade for research. Today, the tools of the trade of research are mobile devices, inexpensive sensors, computing almost too cheap to think about whether it costs anything. And that's driving a huge exploration of things. And I think the broad trend has been fundamentally this, that historically computing was rare and expensive, and now it's become commonplace and inexpensive. And any time a good becomes almost too cheap to meter, you think about how you can use it in broad new ways. That's what's happening now. And that's why it's exciting.
And finally, Mr. Reed, when is Point 9 coming out?
Oh, I never speculate about the future.
Dan Reed works on the future for Microsoft. He's the Corporate Vice President for Technology Strategy, and he's also Corporate Vice President of the Extreme Computing Group. Thank you for being on the Communicators.
My pleasure.
If you'd like to watch this or other Communicators interviews, go to our Communicators website at cspan.org.